sklearn metrics label ranking average precision score. Description. The label ranking average precision score metric calculates the average precision AP for each label in a multi-label ranking problem. It measures the average precision of the ranking produced by the model for each label, considering the order of the labels predicted by the model. This score is a good indicator of the overall performance of the model for ranking labels. Inputs. Why true? This is the true multi-label target vector. It is expected to be a 2D array where each row represents a sample and each column represents a label. The values in the array should be either 0 or 1, indicating the absence or presence of the corresponding label. Y scores. This is the predicted multi-label ranking score vector. It is expected to be a 2D array with the same shape as Y true. Each value in this array represents the score for the corresponding label. Higher scores indicate a higher probability of the label being present. Outputs. Score. This is the average precision AP score for the multi-label ranking problem. It is a single value that represents the average AP across all labels. Steps. For each label, the function calculates the precision at each rank position in the ranking produced by the model. The precision values are then averaged over all ranks to obtain the average precision AP for that label. The AP values for all labels are averaged to obtain the overall label ranking average precision. Score. Metrics. Average precision AP. This is the main metric used by this function. It measures the average precision of the ranking produced by the model for each label. Visualization plots. Precision recall curve. This plot shows the precision and recall for different thresholds. This plot can be used to visualize the performance of the model for each label. Fine-tune parameters. None. The function does not have any fine-tune parameters. Uncertainty methods. None. This function does not provide any uncertainty methods. Challenges and fixes. Challenge 1. The function is sensitive to the distribution of labels in the dataset. If there are many labels with a low frequency, the AP score can be skewed towards those labels. Sample use case that resulted in challenge 1. A dataset with a large number of rare labels may result in a low AP score due to the dominance of these labels. Fixes to challenge 1. Consider using a weighing scheme that gives more weight to the labels with a higher frequency. Alternatively, you could try to balance the dataset by oversampling the minority labels. Challenge 2. The function is not robust to noisy data. If the dataset contains a lot of noise, the AP score can be significantly reduced. Sample use case that resulted in challenge 2. A dataset with a high level of noise may result in a low AP score due to the misclassification of labels. Fixes to challenge 2. Pre-process the dataset to remove noise. Use a robust learning algorithm that is less sensitive to noise. Consider using a different metric that is less sensitive to noise, such as the F1 score.